So here we have the Heathkit Condenser Checker C3, and we've done some repairs on it, replaced all of the paper capacitors in it, replaced the electrolytic capacitors in it, replaced a lot of the resistors in the voltage divider that sets the voltage for checking electrolytic caps for leakage. We did one modification to it to set the 25 volt leakage scale to be something close to 25 volts. As these kits were produced, they actually put out around 40 volts on that setting, and that just didn't seem right to me. You have the front label to 25 volts. You have the specifications in the manual saying 25 volts. And when you do the calculations on the resistors that were in there, it comes out to 40 volts on that setting, and that's what I was measuring. So I went ahead and made a modification to that to bring that voltage down to 25 while leaving the rest of the voltages about where they were, which were pretty close to the 150 volts, 250 volts, 350, and 450 volts. So now that that's all done, one other thing I did is the knobs in these two positions were cracked on the inside, and so you couldn't tighten them down very tight. And I ended up filling those with a plastic epoxy that I got from Harbor Freight, letting that dry, and by filling up all of those air pockets in the back side of the knobs, it really stiffened up the knob themselves and made them more robust. So now I was able to tighten those down just fine with no problems. So with all of that done, let's see how it checks out on a resistor and some capacitors. We have a 200,000 ohm capacitor here, 200K. It's only a 5% resistor. It reads about 203K with my Fluke multimeter here. If I go across it, 202.8, that's pretty close, 203. So now if we put that in the old C3 capacitor tester, and we'll be able to compare the reading that we get on here with what the Fluke has, which should be pretty close. Of course, you won't have the degree of precision that the Fluke has, but for just generally testing, go, no-go conditions, this should work out okay. So you read resistance on these outer scales here, and we have it on the R times 100 scale. So on the R scale, 100 times 100 would be 10,000, 50,000 for 500, 100,000 when it's on 1,000, 200,000, 500,000, 1 megohm, and 5 megohms. So as we move this up towards the 200,000 range, which would be right in the middle, we should see this eye tube start widening out. And there it's doing that. And you can see it's just shy of 200,000 there. So that's pretty close. I don't know if you can see that. Let me see if I can zoom in on that a little bit. So you can see the eye tube there. It'll close. Then as it gets close to 2,000, 200,000, it opens back up. So that's pretty good. Now let's check a few capacitors. Here we have a 0.1 microfarad. So 0.1 microfarad would be set. That goes to 0.005. So this one goes 0.001 to 0.5. So that would be the middle scale here. That's 0.001, 0.005, 0.01, 0.02, 0.05, 0.1 should be over here somewhere. Now again, I don't expect a lot of accuracy out of this, but it'll be interesting to see what we get. Especially at these low values. Well, let's start all the way down there, bring it up, and it's starting to open right there. Boy, that's pretty close. That's just shy of 0.1, so that's a good test. Let's check a 2.2 microfarad. So on that we go to the 0.1 to 50 scale, which is this second set of scales. So 50 would be way over, oh wait, we're looking at 2.2. 2.2 should be somewhere near the middle there. So since it's an electrolytic, I don't think it matters on the value part. We put the negative in the right hand side, positive in the red. I'll have to make a couple of clip leads for these to make this a little faster. Okay, so we expect that to be somewhere around the 2. Let's see. I don't know if you can see that or not. Let's get a little closer. So we'll come back this way. Starting to open. Open right there. So that's looking like about 2.3, I'd say. 2.3 microfarad. And this is labeled as a 2.2. So that's really close. Let's see if the fluke can read this. Fluke reads it as 2.6. Go to another scale. Here we have a 100 microfarad. So in 100 microfarad we go to the 20 to 1000. In the 20 to 1000 range is this innermost range. So 100 microfarad will be over here on the right. There, it's got a wide range there, but it gets the widest right around 100 microfarad. Very nice. And then finally, we have a 470 microfarad. 470 will be down here near the 500. There, it's got a wide range also, but it looks like it's widest right there, which is, yeah, the scale is really compressed there, but I'd call that 400 microfarad. So probably not as accurate, on that really compressed scale, but again, kind of a good for a quick check. The fluke reads this as 500 and actually 611. So not as accurate on the high-end scale. So let's check some leakages. This is a 35 volt capacitor, so I'll check that on the 25 volt scale. And these should be good. They're old capacitors, but they've never been used. And this shouldn't matter where this is. We'll go to the 25 volt scale, and when you check these, you would expect the eye tube to close quickly and then open quickly, probably within a second. Let's see what it does. Oh. Closed all the time. That doesn't seem quite right. Check another one. This is only a 16 volt. That acts the same way. This one's 160 volt. Oh, I see. I forgot. This switch says paper and mica, I believe, needs to be in electrolytic position. So this is 160 volt. Yeah. So you saw that the eye tube closed and then opened almost immediately. So that's a good cap. Let's go back and check those other ones. So 16 volts, so I'm overvolting this a little bit, but I think it'll be all right. Kind of slow opening up. And then this one was 35 volt. Yeah. That's probably good. So it closes and then opens back up and doesn't take, tens of seconds to do it. So yeah, that's important to have that on the correct setting, either electrolytic or paper and mica. So let's check some of the capacitors that came out of this unit see if we find any leaky ones. So this is a 8 microfarad, 475 volt. I'm going to go ahead and use test leads on these. Some of them are too short. Okay, the positive is over here. Positive goes here. Negative goes here. 475 working voltage. So this goes on the 450 scale. And check the leakage. Maybe a little leakage. It didn't open up all the way. See how wide it is there? And it's only about half as wide there. A little bit of leakage. And this was 8 microfarad. Let's just check the capacitance. Right there. We're on the 50 microfarad scale. So that shows about 10 microfarad. Another one here. Same situation. 8 microfarad at 475 volts. Reads about the same capacitance. Leakage about the same. Then we have some paper capacitors. The old plastic encapsulated. This is a 0.05 at 600 volts. So this one would go to paper and mica. Even though these have a stripe on them, they are not polarized. That simply indicates which lead has the foil on the outside for shielding. So 0.05 at 600. Check the leakage. That's leaky. Yeah, kind of slow. Probably not terrible. If we can find the value, value's about right there, right around 0.05. This one, 0.01 at 400. Pretty close to 0.01. We'll test it on the 350 volt scale. That's a good cap. See how quickly that recovered? That last one recovered much slower. Here we have two 0.01s at 400 in parallel. So the 0.01s, oh, we're on leakage right now. Let's check the leakage first. Pretty slow to recover. I'd say those are a little leaky. Point 0.01 would be this scale. And it's opening up. Okay, should actually be 0.02 because they're in parallel. 0.02. Let's look on this scale. Give us a little better reading. So, a little over 0.025 maybe, 24. Then we have a 0.25 microfarad at 600 volts. This one actually says outside foil on it. .25 at 600 volts. 0.25 should read okay on this scale. 0.1's there, 0.5's there, so a little more than halfway between them. Pretty close. That's a whopping 600 microfarad, or 600 volt. So, yeah, that's up. Yeah, this is not an electrolytic. So, totally leaky. This doesn't open up at all. It's terrible. Finally, our last one, 2 microfarad at 200 volt. Big old wax paper capacitor. 2 microfarad at 200 volt. So let's go to the 150 volt scale. Check the leakage. Very leaky. Not moving at all. So that's bad for the leakage. And 2 microfarad should be on this scale. Pretty close to 2. 2.2 I'd say. So yeah, even though these might read okay from a capacitance standpoint, check this on our fluke. 3 microfarad, you'd say, yeah, that's a good cap. But the leakage says it all. The leakage is like putting a giant resistor across that and letting that voltage leak from one side to the other. So that's about it. I'm going to call this good. It'll be a useful addition to the bench, and glad I put the work into it. Thanks for watching.